We are now in the chapter 3, actual vapor compression cycle. So, as the refrigerant flows through the system, there will be a pressure drop in the condensers, evaporator and piping. So there will be also head losses or gains will occur depending on the temperature difference between the refrigerant and the surrounding. So the compression will be polytropic. So before that is isentropic, no? With friction and heat, so that transfer instead of isentropic. The actual vapor compression cycle may be some or all the items of departure from simple saturation cycle. Now, for the actual, so we have your process. So we have process 1, that will be the superheating of the evaporator 10 to 11. So if I will going to draw the pH diagram, so we have here the process starting in the on the suction of the compressor. So we have the process 10 to 11, which is superheating. Then we have the next process, that will be the heat gain in the suction line. So that will be the 11 to 12. Okay, so that will be the line. So that is the heat gain. Then next we shall have number 3, the pressure drop in the suction line, that will be 12 to 13. Okay, so see the difference from the simple saturation cycles, such a simple vapor compression cycle. So then next we shall have point number 4, that will be the pressure drop due to wire drawing at the compressor suction valve. So that will be 13 to 1. So ito yon, starting from here we have your 13 at this side and going to 1. Then next we have number 5, that will be the polytropic compression with friction and heat transfer 1 to 2. So we have here the polytropic compression. So usually our compressor, as you going to compress, you will be rejecting heat, and the same time it also has a heat transfer to the environment. So that will be the actual, no? Then next we shall have pressure drop number 6, pressure drop at the compressor discharge valve 2 to 3. So if we're going to draw that one, so you will notice here from the discharge of the compressor, so there will be a corresponding pressure drop, no? So due to the friction and also losses due to the piping on the valve discharge line. Then number 7, we have the pressure drop and delivery line 3 to 4. So if we're going to draw that one, so starting from here going here, so 3 to 4. Then next we have heat loss in delivery line 4 to 5. So we have here heat loss in delivery line. So when we say delivery line, that will be the piping from the compressor going to the condenser. Then next we shall have pressure drop in the condenser 4 to 6 going to the condenser. So from the compressor going to the condenser, so we shall observe also a pressure drop. Then we have 10, the subcooling of the liquid in the condenser or subcooler. So if you can draw that one, interpret in page diagram. So it proceeds on this side. Okay. Then next we have heat gain in the liquid line 7 to 8. So if we're going to interpret that one, so that will be going back here. Then we shall have going down here for the expansion of your expansion valve. Then we have 12, that will be the pressure drop in the evaporator 9 to 10. So we can close now the cycle. So the pressure drop in the evaporator is large. So you will notice here the evaporator. So we have here the evaporator side and we have here the condenser side. So the pressure drop in the evaporator is large, that in the condenser is small. So you will notice also the difference. Due to the various pressure drops, the capacity of the plant, so it usually increase, and we have the corresponding increase of power consumption due to the decrease of the efficiency of the plant. Now, the COP of the actual cycle is being reduced. So we will be having a sample problem on these ones so that we can be fully understand what is happening in actual vapor compression cycle. So this will be discussed on the next video.